Now let's look at two common conditions to demonstrate how these two hormones function in our everyday lives. Click the dehydration button to see how the hormones respond when you lose fluid through perspiration. In dehydration, which could be caused by hot weather, perspiration causes the body to lose both water and sodium. In response, both ADH and aldosterone are released. They stimulate the kidney to conserve body fluid by increasing reabsorption of water and sodium ions from the filtrate. Therefore, the volume of filtrate entering the medullary collecting duct is reduced, so urine volume decreases. Overhydration, which could be caused by drinking several cans of soda or other beverages, triggers a decrease in ADH and aldosterone levels. As a result, membrane permeability for water and sodium ions decreases, reabsorption slows dramatically, and the volume of filtrate entering the medullary collecting duct increases above the normal level, causing urine volume to increase. High urine volumes also occur when substances containing diuretic chemicals are consumed. The osmotic gradient constructed by the countercurrent multiplier mechanism concentrates the urine by drawing water from the filtrate as it travels through the medullary collecting duct. However, the degree of concentration is regulated by antidiuretic hormone, which controls the water permeability of the duct. As seen earlier in this topic, ADH levels vary in response to various conditions, including the individual's hydration status. Select the normal level of hydration first by clicking the Normal button, and then compare that condition with the other two hydration levels. Notice the effect of each condition on the drop of filtrate traveling down the medullary collecting duct. With normal hydration and levels of ADH, water channels are present in the luminal membranes of these cells, resulting in moderate water permeability. ADH also facilitates the diffusion of urea out of the medullary collecting duct into the interstitium. Although it is considered a nitrogenous waste product, urea is responsible for up to 40% of the medullary interstitial osmolarity. From the interstitium, urea passively re-enters the filtrate in the loop of Henle and recirculates back to the collecting ducts. It may then again diffuse into the interstitium or pass into the renal pelvis as a component of urine. Notice that as it descends, the filtrate drop shrinks in volume and darkens slightly as water is lost and solutes are concentrated. The filtrate does not equilibrate with the osmolarity of all medullary regions and is therefore not as concentrated as possible. Normal urine has an osmolarity of about 600 milliosmoles, or twice normal body osmolarity. With dehydration, a high level of ADH creates two important changes. First, it causes additional luminal water channels to be added to the duct, which increases its permeability to water. Second, it increases the permeability of the duct to urea, which in turn increases the interstitial osmolarity. This increased osmolarity draws additional water from the filtrate. Therefore, as the filtrate passes through the lumen of the duct, it equilibrates with each regional increase in osmolarity. Notice the decrease in size and darkening color of the filtrate drop as it descends through the duct. In severe dehydration conditions, the low volume of urine excreted may be concentrated to about 1,400 milliosmoles, or more than 4 times the osmolarity of normal body fluids. With overhydration, ADH levels are very low or absent, and the duct cells remain relatively impermeable to water and urea. The reduction in urea permeability decreases the medullary interstitial osmotic gradient, reducing the water-drawing power of the interstitium. As the filtrate passes through the lumen of the medullary collecting duct, It does not equilibrate with any regional change in osmolarity and therefore remains unmodified. Notice that the filtrate drop remains the same size and color as it descends through the duct. The final urine, which is dilute and high in volume, may have an osmolarity as low as 100 milliosmoles.